Hey everybody, Mr. Bucko here with a problem from your Chapter 14 practice test that's involving arcs and inscribed angles and things of that nature. This problem I got a couple questions on, so we'll do this one together here. And it says in the figure given below, we have that the measure of arc PQ, I know it's an arc because that's a little curvy thing there, is equal to the measure of the arc QR. So those two arcs are right here. Here's PQ. This is PQ from P to Q. That's the arc, P to Q. And this arc is exactly the same length as Q to R. So from here to here. So those two arcs are the same because we're told they're the same. And then we have the measure of angle PQR is equal to C. So angle PQR is this angle right here. And we know that that angle is equal to C. So we can kind of fill that in right there because it says that it's equal to C. And we need to find the measure of the minor arcs PQ and QR. That's these two things right here in terms of C. So when we say in terms of C, that basically means that we're going to have a C in our answer. And we're going to have a C in our answer because we don't know what the value of C is, and we don't have enough information to find out what C is. So when it says find something in terms of, in this case, C, that means that we're going to have a C in our answer because we don't know what C is, but if we did, we have a formula or an equation to plug it into to find the value of whatever it is that we're looking for, in this case, PQ and QR. We're going to have a C in our answer. So we need to find the lengths of PQ and QR. We know they're the same, so that's nice because once we find one, we'll have the other. And we know that this angle right here, PQR, is C. This angle PQR is an inscribed angle. That means that the vertex of the angle right here is on the circle. And since the vertex is on the circle, it means that the intercepted arc of this angle is twice this angle measure. So if we see what arc this intercepts, PQR intercepts the arc from R all the way around to P. So the intercepted arc of angle PQR is this red arc here, because this angle opens up to that or intercepts that part of the circle. And the length of the red arc, the length of the intercepted arc with respect to the angle, is double. So if this is C, that means that this red arc has to be 2C, because an inscribed angle and its intercepted arc are related by a factor of 2 or 1/2 if you're going the other way. So twice this angle is this arc. So that's not what we're looking for, however. We're looking for these two arcs right here. But we'll notice that those two arcs make up the remainder of the circle, and we know that there are 360 degrees all the way around the circle. So that means that these two arcs together, PQ and QR, have to be 360 minus the 2C. So the green arc here, which is PQ and QR, that has to add up to 360 with this red arc here because the whole circle is now accounted for. So that means that this green arc has to be equal to 360 because there are 360 degrees in the entire circle, minus 2C because we don't need the red arc. We just want to know the lengths of these two. So this value right here, 360 minus 2C, is equal to these two arcs put together, PQ and QR. But we want to know each of them, PQ and QR, individually. This is them together, but we know that those two arcs are equal to each other. So if we take this, 360 minus 2C, and simply divide it by 2, we'll get the measure of each of those individual arcs. So we have this, 360 minus 2C divided by 2. This can actually further be simplified because we can divide both terms in the numerator by 2. So our answer will be 180 minus C. This is the arc of PQ and QR because they're both the same. So now the value in this is if we know how big this angle is, we can find out how big the arcs are. But we don't know how big angle C is. We don't have enough information to figure it out. But if we did know how big it was, we would just take that value, subtract it from 180, and that would be the arcs, PQ and QR, because they're the same.